In the beginning, there was emptiness, a silent cosmos stretching beyond comprehension, a canvas of darkness unmarked by form. No mountains, no oceans, no light. Only infinite potential and the subtle hum of possibility. Among that silent nothingness, a force stirred, invisible yet powerful, patient yet relentless. That force was gravity, the sculptor the universe would one day rely upon to carve worlds, to gather dust into planets, and to breathe life into chaos. We seldom notice gravity. Its touch is gentle. We walk, we stand, we fall, and it remains invisible. Yet it shapes our world in ways so deep we forget it. It bends light, curves space, pulls rivers, nurtures mountains, tethers oceans, and anchors our bodies to Earth. But for most of human history, gravity was a mystery, a subtle whisper, not a defined force. Ancient civilizations looked at the sky, traced stars, worshipped celestial bodies, built monuments aligned with the heavens. They marveled at cycles, day and night, seasons, tides, eclipses. But no one understood what held worlds together, what whispered to stones and clouds, what shaped orbits and waters. Gravity remained unknown, a silent hand behind every phenomenon, unseen and unfelt beyond ordinary sight. On Earth, life unfolded ignorant of the cosmic sculptor. Roots burrowed downward, rivers carved valleys, mountains rose slowly under shifting plates, all guided by gravity, but unrecognized. Plants reaching skyward, animals walking upright, oceans swirling in tides, all danced to a rhythm set by gravity's invisible pull. And humans, born into this dance, rarely pause to wonder, who choreographs the motion? It is easy to accept weight as mere heaviness, to treat falling as simple descent, to overlook the gentle pull that keeps our feet on the ground. But somewhere in the vastness of space, beyond stars and nebulae, the same force lingers, drawing dust into clouds, pulling gas into glowing stars, shaping galaxies, guiding orbits, setting the stage for planets, moons, and eventually life. In our story, the unknown begins with a question both intimate and cosmic. What invisible force can build worlds from emptiness, stars, planets, oceans, continents, living beings, from a swirling chaos of particles and energy? We glance at mountains, at seas, at clouds, at trees reaching high, at children laughing and running, and we experience gravity's gift, but we do not know its name. For centuries, philosophers speculated. Some spoke of elements and essences. Others imagined cosmic sympathies and balances. In ancient Greece, thinkers like Aristotle discussed what made things fall, but they could not conceive of a universal force binding all things across space. To them, weight was a property, not a relation. Even as the Middle Ages passed, humanity built cities, sailed oceans, measured seasons, mapped the stars, but gravity remained hidden, mystery masked by familiarity. It was like the air we breathe, essential, omnipresent, yet unseen, unexamined. Then came the dawn of modern thought, a time when curiosity awakened, when the unknown became a frontier, when minds dared to ask, why do apples fall? Why do the moon and planets move? Yet, before these questions could be asked, before experiments could begin, gravity held its secret still. It was patient. It waited. It wrapped the cosmos in invisible threads, spun galaxies, bent light, shaped tides, all in silence. This is the unknown we must confront, a force that binds across unfathomable distances, that sculpts worlds, that shapes the ebb and flow of matter and life, yet remains unseen. Today, when you look up at the night sky, when you see distant stars glittering like distant lanterns, remember, between you and those stars lies the same force that pulls your feet to the ground. Every planet orbiting a sun, every moon circling a world, every ocean rising and falling at shore, all are shaped by gravity's quiet hands. And deep inside you, in the rhythm of your heartbeat, in the falling of a leaf, in the swirl of clouds overhead, gravity whispers its presence. This is our beginning, a journey into the invisible, a quest to understand the sculptor of planets, the binder of atoms, the silent architect of life. The unknown beckons. Its name is gravity. and the universe is waiting for us to learn its language. The earliest experiments were simple, yet profound. Aristotle claimed heavier objects fall faster than lighter ones. To him, matter carried its own motion, a belief accepted for centuries. It took observation, ingenuity, and defiance of accepted authority to see further. The 16th century sparked change. Galileo Galilei, standing in Pisa, dropped spheres from the Leaning Tower, or so the legend goes, challenging the Aristotelian dogma. He showed that all objects fall at the same rate, regardless of weight, when resistance is negligible. His experiments were simple: inclined planes, rolling balls, careful measurement of time with water clocks. Yet their implications were profound. Motion could be understood, quantified, and predicted. The universe was no longer a mystery of whimsy, it had laws. Galileo's work was the foundation. Gravity could be measured. Gravity could be described. It was a universal effect, not a property confined to Earth. But how far did it reach? What pulled the moon toward Earth, yet never let it fall completely? What caused planets to orbit the sun instead of drifting off into nothingness? The answer emerged in the 17th century, when another mind of extraordinary clarity, Isaac Newton, combined observation with mathematics to conduct the greatest conceptual experiment of all, thought itself. Newton did not drop objects from towers, he imagined them. He envisioned an apple falling, not as a singular event, but as part of a universal story. He asked, if the apple falls toward Earth, does the moon also fall? And if it does, what force pulls it? Using careful calculation, Newton formulated the law of universal gravitation. Every particle in the universe attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them. Suddenly, falling apples and orbiting moons were governed by the same invisible hand. Experiments could now include not only laboratory tests, but also celestial observation. To test this, astronomers began measuring planetary motions with unprecedented precision. Observatories across Europe, from Greenwich to Paris, charted the stars. They measured the wobble of planets, the position of moons, and the curvature of comet tails. The predictions from Newton's equations matched observations. Gravity, once invisible, was now quantifiable, predictable, and universal. Meanwhile, experiments continued on Earth. Pendulums, carefully timed, demonstrated gravitational acceleration. Galileo's findings were refined with precise clocks. Cavendish, in 1798, executed an experiment to measure the gravitational constant, the first quantification of the force itself. Using a torsion balance and lead spheres, Cavendish weighed the Earth by detecting the faint pull between masses. This was gravity made tangible, measured, and understood in a laboratory setting. Yet, even as classical experiments advanced, gravity retained its mysteries. How could it act across empty space? What connected objects separated by millions of kilometers? The next era of experimentation required imagination as much as instrumentation. In the 19th century, scientists like Henry Cavendish and later Simon Newcomb refined measurements, studying tidal forces, the motion of the moon, and perturbations in planetary orbits. Physics laboratories measured acceleration, pendulum oscillations, and spring displacements. Every measurement confirmed Newton, yet hinted at subtler phenomena. Mercury's orbit deviated slightly from predictions. Gravity, it seemed, held secrets even in the precision of its reach. By the early 20th century, the nature of gravity itself became the subject of revolutionary thought experiments. Albert Einstein imagined riding a beam of light, falling freely, and observing acceleration. He conceived that gravity might not be a force acting at a distance, but a curvature in spacetime, an experiment conducted entirely in the mind, yet rigorously logical. His thought experiments were validated later by physical ones. The bending of starlight during solar eclipses, measured by Arthur Eddington in 1919, confirmed the predictions of general relativity. Gravity had revealed a hidden dimension, not merely pulling masses, but sculpting the fabric of the universe itself. Simultaneously, in laboratories, experimentalists tested gravity at small scales. Torsion pendulums, interferometers, and vacuum chambers measured gravitational forces between small masses. Satellites like LEGIOS mapped Earth's gravitational field. Experiments aboard spacecraft detected subtle deviations, confirming Einstein and probing anomalies. Gravity, once invisible and mysterious, became a measurable, manipulable phenomenon, yet still awe-inspiring in scope. In the natural world, gravity's experiments are ongoing and eternal. Planetary formation itself is an experiment of cosmic scale. Gas clouds collapse under gravity, forming stars, planets, and moons. Supernovae scatter elements, and gravity binds them into new systems. Rivers carve valleys, glaciers shape mountains, and oceans rise and fall in tidal harmony. Life itself experiments with gravity. Plants grow upward, roots reach downward, animals develop locomotion tuned to the pull of the earth. Every form of motion, every structural adaptation, is a small-scale experiment in gravitational consequence. Even today, humanity continues to probe gravity. LIGO's detection of gravitational waves confirms ripples in spacetime caused by merging black holes. Experiments on a cosmic scale. Satellites measure minute variations in gravitational acceleration to map Earth's interior. Gravity assists propel spacecraft across the solar system, exploiting planetary motion in a dance choreographed by centuries of human understanding. Through every experiment, from falling apples to colliding black holes, one truth emerges. Gravity is both simple and profound, gentle yet omnipotent. It is the silent sculptor that builds worlds, shapes lives, and connects every particle in the cosmos. Human ingenuity has made it observable, measurable, and predictable, yet its majesty remains. Every experiment brings us closer, but also deeper into awe. If experiments showed us the existence of gravity, revelation illuminated its true nature, the cosmic significance of the invisible sculptor. It is one thing to measure falling apples, pendulums, and planetary orbits. It is another to understand gravity as the very architect of structure, life, and motion across the universe. G of force. The first great revelation came with Isaac Newton in the 17th century. By combining careful observation with mathematics, he demonstrated that a single law could describe the motion of both an apple and the moon. This insight was breathtaking. The same force that pulled an apple to Earth governed the dance of celestial bodies across space. It revealed unity in nature, a cosmos bound by invisible, universal laws. Newton's equation, F equals G asterisk, mm2, slash or superscript 2, made gravity quantifiable, yet its implications were immeasurable. For the first time, humanity could see the cosmos as an interconnected system. Gravity was no longer local. It stretched across vast distances, linking planets, stars, and galaxies in a cosmic embrace. Orbits were not random, tides not coincidental, and planetary formation not chance. Every celestial motion followed a rhythm, a pattern written in the lingua. Centuries later, Einstein's theory of general relativity expanded this revelation. Gravity was no longer a mysterious tug at a distance, but a curvature in the very fabric of space and time. Massive objects bent spacetime, creating the motions we observe. Light itself could be deflected by gravity. The universe, once imagined as a static stage, was revealed as a dynamic, malleable entity, where mass and energy sculpt the very geometry of existence. Through this lens, revelation extended beyond numbers and equations. Gravity became a force of creativity, shaping galaxies into spirals, binding clusters into cosmic filaments, sculpting planets from dust, and gathering atoms into worlds capable of sustaining life. Without gravity, stars would never ignite, planets would never coalesce, and water would never pool to nourish life. Gravity is the unseen artist whose medium is matter itself. Consider the solar system. The Sun, holding 9 planets in its orbit, is the result of gravitational collapse of a molecular cloud billions of years ago. Gas and dust spiraled inward, collisions heated matter, and gravity guided particles into ordered rings. The Earth formed, not by randomness, but by gravity's subtle orchestration. Oceans collected in low points, continents emerged through tectonic processes influenced by mass distribution, and the moon was captured or formed in collision, all dictated by gravitational choreography. Revelation deepened with the discovery of gravitational waves in the 21st century. LIGO's detection in 2015 confirmed that massive events, colliding black holes and neutron stars, ripple through spacetime itself. We realized that gravity communicates across the cosmos, carrying information about the most violent, energetic processes imaginable. These waves are whispers from distant cataclysms, telling us about the universe's history, structure, and dynamics. Gravity, once invisible and local, became a messenger, linking humanity to events billions of light years away. Even on Earth, the revelation is profound. Gravity shapes oceans and atmospheres, guides rivers to the sea, drives weather patterns, and dictates the architecture of life. Plants grow against it, roots reach for it. Animals adapt their forms to move efficiently under its influence. Human engineering relies on it. Bridges, skyscrapers, dams, satellites, all are designed with gravity in mind. We do not merely experience gravity, we collaborate with it, respecting its constancy, predicting its effects, harnessing its rules. Moreover, gravity's role in evolution is subtle yet foundational. Life emerged in water, where gravity's pull is mitigated. Later, organisms adapted to land, developing skeletons, muscles, and circulation systems to counteract gravity. Every bone, ligament, and heartbeat is a testament to this sculptor's influence. Without gravity, evolution itself might have taken a radically different path. No towering trees, no flying birds, no creatures capable of walking upright, no sentient observers contemplating the cosmos. The revelation extends into the abstract as well. Gravity is a metaphor for connection, a reminder that everything exerts influence, however invisible. Stars affect planets, planets affect moons, moons affect oceans, oceans affect life, life affects thought. Human consciousness, too, is drawn by gravity, by the gravity of curiosity, the pull of understanding, the orbit of reflection around truth. The universe is not separate from us. We are a continuation of its gravitational story. And yet, revelation is not only intellectual, but emotional. To understand gravity is to see the poetry in every falling leaf, every tide, every orbiting planet. It is to recognize that the pull binding galaxies is the same pull that holds our feet on Earth. There is a humbling, almost spiritual, awe in realizing that we live within a force that shaped the cosmos long before we existed. We are, quite literally, participants in a dance choreographed by an unseen hand stretching across time and space. Gravity's revelation also bridges science and imagination. It allows us to predict phenomena, explore the cosmos, and imagine distant worlds. It underpins satellite navigation, space travel, and predictions of climate and tides. It guides astrophysicists modeling galaxy formation and engineers planning interplanetary missions. Every insight into gravity brings with it the thrill of understanding and the responsibility of knowledge. Thus, the revelation of gravity is not a single event but a cascade, from falling apples to orbiting planets, from equations to space-time curvature, from local pull to cosmic waves. It transforms invisible force into an elegant framework for the universe. It reveals order in apparent chaos, purpose in cosmic motion, and connection in separation. We now understand that gravity is the sculptor of planets and life, the architect of oceans and mountains, the invisible hand guiding matter from nebulae to neurons. It is the quiet conductor of the symphony of existence, omnipresent and eternal. As we step away from this revelation, we prepare to see its consequences, not only in equations or celestial mechanics, but in life, civilization, and our daily experience. Gravity is no longer a mystery. It is a guide, a maker, a force whose effects ripple across every scale, from the tiniest atom to the vastest galaxy. Gravity's revelation reshaped not only science, but also our perception of existence. It is a force invisible to the eye, yet its consequences ripple through every corner of the universe, touching matter, life, civilization, and even the human imagination. Understanding gravity transformed how we move, how we explore, and how we see ourselves in the grand cosmic tapestry. On a cosmic scale, gravity is the architect of structure. Galaxies spiral, stars form, planets coalesce, and black holes emerge, all because of this silent pull. Without gravity, matter would remain dispersed in chaotic clouds, and stars, and with them, life, would never ignite. Gravity is the invisible sculptor, gathering atoms into complex forms, orchestrating collisions, ignitions, and accretions that birth solar systems. Every planet in the universe, including Earth, owes its existence to gravity's precise, patient hand. The consequences extend directly to life on Earth. Gravity shapes oceans and atmospheres, driving currents and weather patterns. Tides rise and fall, a rhythmic pulse dictated by the gravitational pull of the moon. This cyclical motion regulates marine ecosystems, distributes nutrients, and influences migration patterns. Rivers carve valleys, glaciers shape mountains, and winds interact with pressure differences, all guided, directly or indirectly, by gravity. Life evolves within this framework, adapting to the pull that defines dimensions, orientation, and movement. Human physiology is also a testament to gravity's influence. Muscles develop, bones strengthen, and the cardiovascular system circulates blood against the downward pull. Life adapted to resist gravity, building intricate structures capable of motion and balance. When gravity is altered, in microgravity environments aboard spacecraft, human bodies undergo profound changes, highlighting just how deeply this force governs biological processes. Evolution itself was conducted under gravity's watchful pull, shaping everything from seed dispersal to skeletal architecture. Civilization, too, carries gravity's imprint. Ancient builders designed pyramids, temples, and aqueducts with the pull of Earth in mind. Modern engineering relies on precise calculations of gravitational force to erect skyscrapers, bridges, and dams. Space exploration, the ultimate human endeavor, depends on gravity's predictable behavior to navigate planets, moons, and spacecraft. Gravity assists propel probes across the solar system, using the pull of planets to accelerate journeys to distant worlds. Without understanding gravity, human ambition would remain earthbound, literally and figuratively. Gravity also influences technology and research. Instruments measuring gravitational anomalies map Earth's interior, detect underground resources, and monitor changes in ice sheets. GPS systems, reliant on satellite positioning, must account for relativistic effects of gravity on time. Particle accelerators simulate conditions influenced by gravitationally stable mass. Even energy generation, from hydroelectric dams to nuclear reactors, interacts indirectly with gravitational principles. Knowledge of gravity enables innovation, exploration, and the creation of infrastructure essential to modern life. On a philosophical level, gravity has consequences for human consciousness. It anchors not only our bodies, but also our perception of stability and order. Awareness of gravity connects us to the cosmos, revealing that every object, from a speck of dust to a distant planet, is interconnected through this force. It is both literal and metaphorical, a reminder that invisible influences govern the visible, that unseen forces shape destiny, and that understanding these forces yields perspective, humility, and wonder. Gravitational insights also redefine time and space. Einstein's theory of general relativity revealed that gravity bends spacetime, causing clocks to tick differently depending on proximity to mass. This understanding reshaped navigation, astronomy, and cosmology. Gravitational lensing allows astronomers to observe distant galaxies, magnifying objects light years away and revealing the universe's history. The consequences of understanding gravity ripple through our capacity to observe, interpret, and act upon the cosmos. Gravity has societal consequences as well. Space programs, satellite communications, climate monitoring, and even disaster prediction rely on precise gravitational knowledge. Understanding how mass moves and interacts informs resource management, flood prevention, and hazard assessment. Beyond practical applications, gravity influences culture. Art, literature, and philosophy draw inspiration from our awareness of forces beyond perception, a constant reminder that humanity exists within a larger, interconnected system. Environmental awareness is also tied to gravity. Planetary ecosystems operate under the constraints of gravitational forces. The rise and fall of tides affect coastlines. The distribution of sediments shapes fertile plains, and atmospheric circulation supports climate patterns. Understanding gravity encourages responsible stewardship of Earth's systems, emphasizing that human activity cannot ignore the natural laws sculpting life itself. Even on an emotional level, the consequences of gravity are profound. Consider the awe of watching a sunset over the horizon. The sun appears to sink, but its fall is guided by the interplay of gravity, Earth's rotation, and orbital dynamics. Every experience of weight, fall, or lift is a connection to the same force shaping stars and galaxies. To grasp this is to connect personally to cosmic processes, to recognize that we are participants in a universe governed by invisible, elegant principles. Gravitational waves, detected in the 21st century, extend these consequences into new dimensions. They demonstrate that cataclysmic events, black hole collisions, neutron-star mergers, reverberate across spacetime. Humanity can now sense distant cosmic cataclysms, experiencing events billions of light-years away. Gravity, once purely local and terrestrial, becomes a messenger across space and time, linking distant phenomena to human observation. The consequences of gravity also touch the origin and evolution of planets themselves. Planetary formation is a consequence of matter collapsing under its pull, accreting into dense cores, shaping atmospheres, and creating conditions suitable for life. The Earth's magnetic field, ocean currents, and climate are intertwined with mass distribution and gravitational influence. Without this sculptor, Earth would not exist as a stable, life-sustaining planet. In summary, the consequences of gravity are vast and intertwined. From the smallest leaf to the largest galaxy, from molecular bonds to cosmic collisions, gravity shapes reality. It dictates motion, structures matter, guides evolution, inspires discovery, and connects consciousness to the cosmos. Humanity benefits from understanding it, respects it, and learns from it, yet its full majesty remains beyond complete grasp, a reminder of both human curiosity and cosmic humility. Gravity is not merely a force, it is a principle of life, matter, and time. Its consequences are tangible, measurable, emotional, and philosophical. It binds atoms into worlds, guides stars into orbits, and supports life in its intricate balance. To live is to exist under its influence, to move within its constraints, and to marvel at its invisible artistry. As we move from consequence to reflection, we carry with us a deep understanding. Gravity is both the engine and the artist, the sculptor and the law, shaping not only the universe, but every heartbeat, every tide, and every thought. Its consequences are our inheritance, our foundation, and our link to the cosmos. Having journeyed through the unknown, traced the experiments, and witnessed the revelations and consequences, we arrive at reflection, the quiet space where the story of gravity becomes a story of ourselves. Reflection is not merely looking back. It is the act of synthesizing knowledge, wonder, and meaning. It is where science meets philosophy, where observation becomes meditation, and where human curiosity finds humility and awe in the cosmos. Reflection begins with awareness of presence and scale. Gravity is universal, invisible, yet omnipresent. Every breath we take, every step we make, every heartbeat we feel is inextricably linked to this silent force. The atoms in our bodies were sculpted under gravity's influence. Our very existence is tethered to its pull. Reflection is the recognition that we are participants in a cosmic narrative, a narrative where stars collapse, planets form, and life emerges, all guided by the same force that keeps our feet planted on Earth. Consider time. The particles in our cells have histories older than Earth itself. Hydrogen formed in the first seconds after the Big Bang. Carbon, oxygen, nitrogen, and iron were forged in generations of stars that lived and died billions of years before life existed. Gravity shaped those stars, governed their collapse, and orchestrated the dispersal of elements across the cosmos. Each breath, each heartbeat, each thought is an echo of processes guided by gravity, processes that began long before human consciousness existed. Reflection is the act of holding this temporal vastness in the mind, of understanding our fleeting yet meaningful presence in the universe. Reflection illuminates the extraordinary rarity and fragility of life. Gravity's precise, consistent pull allowed planets to form, oceans to pool, and atmospheres to stabilize. Without it, stars might never ignite, planets might never coalesce, and life might never arise. Earth exists at a delicate nexus of distance from the sun, composition, and planetary mass, conditions tuned by gravity over billions of years. Reflection inspires gratitude. Gratitude for the opportunity to exist, to observe, and to derive meaning from the universe. Humanity's journey of discovery mirrors the cosmic processes sculpted by gravity. Just as matter collapses into stars, planets, and moons, human minds fuse curiosity, imagination, and experimentation to reveal the universe's secrets. Reflection shows that science is a continuation of the universe's creative processes. Each experiment, each observation, each insight is a microcosm of cosmic evolution. Gravity, once invisible, becomes a guide for understanding, a principle that bridges human thought and cosmic structure. Philosophically, reflection bridges the gap between matter and meaning. Gravity is both a law and a narrative, shaping not only physical matter, but also our perception of order, stability, and connection. The realization that gravity governs the motion of galaxies and the flow of rivers evokes humility. We are part of a grand system far larger than ourselves. Yet this recognition also brings empowerment. Understanding gravity allows us to explore, predict, and participate in the cosmos. It teaches that knowledge is not separate from existence, but a pathway to deeper engagement with it. Emotionally, reflection is profound. Awareness of gravity fosters awe, wonder, and reverence. The tides rise and fall, rivers carve valleys, and leaves descend from trees in perfect arcs, all under its influence. The moon's pull orchestrates the rhythm of life in the oceans. Stars orbit unseen centers in galaxies, their dance dictated by gravitational embrace. Every falling leaf, every rushing river, every orbiting satellite, all bear the mark of this invisible sculptor. Reflection allows us to experience not only scientific understanding, but also the poetry of existence. Gravity also invites contemplation of continuity and interconnection. Every atom in our body has been part of stars, planets, oceans, and living beings. The pull that binds the Earth also binds the moon and planets in orbit. The tides, the rivers, the air we breathe, and the structure of our bodies are all influenced by gravity. Reflection reveals that life, matter, and consciousness are threads woven from the same universal fabric. We are not isolated observers, but participants in an intricate, interconnected cosmic process. On the human scale, gravity shapes thought, culture, and creativity. Architecture, engineering, and art all respond to its pull. Ancient pyramids, Gothic cathedrals, and modern skyscrapers are designed with gravity in mind. Bridges and tunnels obey its constraints, while spacecraft navigate around its curves. Even our imagination bends under its influence. The metaphor of gravity pervades language, symbolizing seriousness, weight, and connection. Reflection shows that understanding gravity enriches every facet of human experience. Moreover, gravity links the microcosm to the macrocosm. The same force that governs galaxies also shapes the motion of atoms, particles, and celestial bodies. Gravitational waves, ripples in space-time from colliding black holes, connect the farthest reaches of the cosmos to instruments on Earth. Through gravity, we sense the rhythm of the universe, the vibrations of matter, the pulses of stars, the dance of galaxies. Reflection allows us to perceive this continuity and to recognize our presence as part of an ongoing cosmic experiment. Reflection deepens ethical and environmental awareness. Planetary systems, oceans, and ecosystems operate under gravitational constraints. Understanding these constraints fosters responsibility for stewardship of our world. Sea levels, river flows, and atmospheric circulation are intertwined with gravitational forces. Human activity must respect these balances. Reflection transforms scientific knowledge into ethical awareness. We live under gravity, shaped by it, and dependent upon it. On a more philosophical plane, gravity teaches us about the invisible forces shaping all aspects of life. Just as gravity binds matter, unseen social, moral, and emotional forces bind communities and consciousness. Reflection draws parallels between cosmic law and human experience. The universe is structured, interconnected, and purposeful, and our actions resonate across both time and space. Awareness of gravity encourages introspection, empathy, and understanding of the subtle forces shaping our existence. Reflection also celebrates wonder and imagination. Gravity, though invisible, is perceptible through motion, measurement, and consequence. Observing its effects, from falling objects to planetary orbits, evokes awe and curiosity. The mind imagines journeys across galaxies, the rise and fall of stars, the fusion of elements, and the evolution of life. Reflection allows us to transform scientific observation into narrative, turning facts into stories that connect intellect and emotion. Ultimately, reflection connects us to purpose. We are observers, participants, and stewards of a universe shaped by gravity. The force that builds planets and guides oceans also guides human understanding. Each scientific insight, each experiment, and each observation is an act of engagement with the cosmos. Reflection is not passive. It is conscious participation in a process that began with the formation of matter and continues in the expansion of knowledge. In contemplating gravity, we recognize our place in time and space. We are products of cosmic processes, yet capable of understanding them. The stars that created the atoms in our bodies also provide the context for inquiry, imagination, and exploration. Reflection allows us to appreciate the delicate balance that sustains life and to marvel at the forces that make existence possible. Gravity is more than a law of physics. It is a bridge between the universe and consciousness, between matter and meaning, between observation and emotion. It reminds us that the cosmos is orderly, interconnected, and majestic. It inspires creativity, humility, and reverence. Reflection transforms understanding into wisdom, connecting knowledge with experience, observation with feeling, and the invisible force of the universe with the visible reality of life. And so, as we conclude this journey, reflection leaves us with clarity and awe. We are children of gravity, sculpted by its pull, shaped by its rhythm, and guided by its invisible hand. Every planet, ocean, mountain, and living being is a consequence of its patient artistry. Every heartbeat, falling leaf, and orbiting satellite is a testament to its constant presence. The universe has built us, nurtures us, and allows us to witness its grandeur. And in reflecting, we recognize that our existence, our knowledge, and our wonder are inseparable from the force that shapes all things, the invisible sculptor of planets and life. Gravity connects the micro to the macro, the transient to the eternal, and the visible to the invisible. It teaches that every motion, from an atom to a galaxy, has consequence. Every structure, from a leaf to a mountain, is guided by its pull. It invites us to observe, to measure, to understand, and to marvel. In this reflection, humanity finds identity, purpose, and inspiration, to study, to explore, and to respect the forces that shape the cosmos and our place within it. Reflection is the final chapter, yet not the end. Gravity continues its work, unseen but omnipresent, shaping worlds, guiding oceans, forming stars, and influencing life. And humanity continues to observe, measure, and wonder, participating in the grand experiment of existence. The universe whispers through gravity, and through reflection, we listen.